plane. Okay. This one. Yes, a very good morning to all of you. Am I audible and visible over there? I'm able to see Sashi and Sandhya, right? There is no problem from the audio and visual. Kalyani here, hi. What is your name here, Kerry? Yeah? Is it the Kerry which is your name? Nah, people will be writing, doing very, like, kind of keeping very fancy kind of name which catches the attention. Harsha here, good morning, beta. Your real name is only that, kya? Okay, then I'm sorry for that. I mean, if at all you felt offensive there. Shri Geeta Lekha. Okay. Fine. Then how is your studies going on there? How is our preparation? And the thing is, it's always better to, kind of from the day one, you should be quite enthusiastic about your preparation. Whatever is the external atmosphere, whichever is existing now, that's not in our hand. That chaos we cannot handle. But the thing is, enthusiasm for our studies and our preparation is in our hand, and we must control it. It is going good? That's good. Okay, without any further delay, let us go for, kind of, what was the last thing which I've taught you in the last class? Does anybody remember? I think we finished off with the F block element, if at all I'm not wrong, or else we just finished off D block element. Sarath Babu is writing chilling with study. Good. F block we have completed. Did I give you the general electronic configuration also? For F block, did we write down general electronic configuration? Yes, we have written that. Okay. And did we write down the two inner transition series which were there in F block? Did we write down that? 4F inner transition series, 5F inner transition series also we have written. Okay, so we have mentioned about how many elements there and which period do they belong to. Everything is done there. Okay. Then one note you can write down here, just below that where segment where we have finished. Lanthanum and actinium are D block element, not F block element. Right? At present, you write down this as a note here, and I would like that where you have written, just previous, I think, previous only on that page, you can see that where you have written 4F inner transition series. Beside that, you can write down what they'll be called as lanthanoids or else lanthanides. Lanthanoids or lanthanides, right? 4F inner transition series will be called as lanthanoids or lanthanides. Previously, it was called as lanthanides. Now, more recently, it is called as lanthanoid, right? And I'm not including lanthanum in lanthanoids, right? This is a common misconception which we people carry, that lanthanum is lanthanoid. No, it's not, right? Similarly, where you have written 5F inner transition series, you can write down there as actinoids or actinides. Actinoids or actinides. Hopefully you people have written there actinoids or actinides. So do remember, this is a common misconception that we write down, or else we consider lanthanum to be part of lanthanoids and actinium to be part of actinoids. Okay? And there is like, this could be asked as a potential question also in the examination, right? Why it is called so and all those stuff, we will understand this eventually as we'll progress in this chapter. Okay? Hopefully everybody made that, kind of addition there in their note, right? Now let us go for important points. Important points about the modern periodic table. Important points about the modern periodic table, right? Now, there are few things or few terminologies which we must be clear about, right? And we must be clear about, and the questions can also be asked from that segment, right? Now, if at all I ask you, name a metal from the modern periodic table, or else name a metal which exists in liquid state at room temperature. Name a metal which exists in liquid state at room temperature. That will be mercury, right? If at all I ask you, name a non-metal, correct Sashi, or else Harika also. So the thing is, name a non-metal which basically exists as liquid at room temperature. Non-metal term. Sashi, I hope that is basically your typing mistake. Yes, Vamshi, correct. Kavita. That is bromine, absolutely fine. Can you name few elements which exist in liquid state just above the room temperature? Just above the room temperature. Somebody has written gallium here, absolutely fine, Sandhya. Gallium will be there, cesium will be there, francium will be there. Their melting point is around, kind of 27, 28 or maybe 29. So it is just above the room temperature. When we go, it will be existing in liquid state, right? So that's what we are going to write down here. First one, metal which can exist in liquid state at room temperature. That is basically mercury. Okay. Second one, non-metal which can exist in liquid state at room temperature is basically your bromine. Then the third one, elements existing in liquid state just above room temperature. So that is basically cesium, francium, gallium. You are having mercury and bromine. Need not wonder about mercury and bromine, because mercury and bromine at 25 degrees Celsius, which is the room temperature, when they're existing in liquid state, so definitely at 27, 29, they are going to exist in liquid state itself, right? Rubidium is slightly higher, carry there, around 37 degrees Celsius or something it will be. I'm talking about just above the room temperature, so I'm not meaning much difference there. Now, what is metalloid? Please write this down, and once you write this down, then we'll proceed further, all of you. Kindly write down done if you at all you are done there, then we'll proceed further. We can say semi-metals, or else metalloid means what? Their property will be somewhere, kind of similar, somewhat similar to metals also, non-metals also. In between that we can think of, right? So we are saying metalloids for them, right? So from the modern periodic table, you must know that what are certain elements which we categorize them as metalloid, right? Or else semi-metals, which we say. Now, normally in your periodic table, you might have observed, some kind of elements or some elements which are, kind of making a staircase kind of thing. That means they are present in such position, which seems to appear like a staircase, right? So those elements which are here, I'm writing silicon, germanium, arsenic, antimony, tellurium, statin and polonium, right? These are the elements which will be acting as metalloid, right? Or which are actually metalloids, right? Now, to remember this, there is a small mnemonic. So imagine that normally foreign tourists visit our country, right? So the thing is, every country has got certain rules and regulation, and if people do not follow that, then definitely they will land up in jail or else in police custody, right? So the same thing here. Suppose that German is there, right? He didn't know about a rule and he basically did some mistake. So police has taken him in custody. Now this German fellow, he's quite crazy about some channel there, right? Or some TV channel. Normally some people will be crazy about Cartoon Network or else Sony TV or else any other network. It is individual's preference, right? So here you can think of that there is a sub-television, sub-channel, right? Name of that channel. So he is so much crazy that even in the police station, he is not able to pass his time. So he's just asking, can I get that sub-television here, right, at police station? So rest of the members are saying, how silly of him, silly German here, he doesn't know anything, right? So we are going to write down this as silly German asking for sub-television at police station. Write this down and you have to remember this, right? Now let us go for understanding one more thing here. In the P block, these elements will be there which will be present in the kind of staircase form here, right? So on these staircase, which like arrangement here, so in the P block, do we get metal, non-metal and metalloid, right? So in this case, you remember on this staircase, you are having metalloid. So below that, you will be having metal. Above that, you will be having non-metal. So that's how we say that you are having metal, non-metal and metalloid all existing in basically your P block. Write this down, then we'll proceed further. And now again, see, there could be some confusion around silicon metal because the thing is, thanks to NCERT, they have given you in your modern period, like in your periodic table chapter, they have given you, declared it as basically metalloid. But when you go for studying P block, there they are treating it as non-metal. So it all depends on the option available, right? So silicon ideally should not be given, but if at all given, then you can go for taking mark that as metalloid, okay? Harsha is trying to tell me the mnemonic. What is that mnemonic which you are trying to tell me? Sita Geeta asking what? Complete the mnemonic. Yes, Lakshmi has written a better explanation of it. Are we done writing it? Then we'll proceed for the further. right? In fact, we can also go for this silicon, germanium, so this mnemonic could be like more easier or more relatable. Silly Geeta asking Salman Bhai, where? At tea post. Tea post is the place where people will be enjoying their tea. Right? Silly Geeta asking Salman Bhai at tea post. Right? Tea post is the place, or else a cafe kind of thing, where you will be getting your tea. Right? So one more, if you want to write down, you can write it down. It just struck me, so I've written. Then we'll proceed for the next one. And from Salman Bhai, you will be able to relate more as SB. Are we done? Then we'll proceed further, beta. Now the next one, how many points done here? What is the number with sequence which we are following? Fourth done here. Now let us go for the next one, which is typical element. What is the meaning of the word typical? When I say typical there, what is the meaning of the word typical? Something specific, something peculiar. That's what is the meaning of the word typical, right? Now, leave the element part. Suppose you happen to visit, kind of a foreign country, right? Now, there will be so many people, because anyhow, tourist place, that means there will be so many people there. But out of so many people over there, you are able to identify Indians somehow. You are saying that, okay, this could be Indian, that person seemed like Indian. How there will be certain traits of Indians, right? Certain traits which are common. Maybe we are more religious, and maybe we are more respectful towards the elders, right? And maybe we do not prefer much of burger, pizza, like that. Our food choices are different, right? So maybe depending on that, you might feel like, or maybe we are rushing more towards Indian restaurant even in foreign country. That is our food choices. So based on those traits, so you were able to identify maybe this could be Indian, right? So those were the typical traits or typical characteristic of Indian, right? So that's how you identified, right? So I'm not saying that everyone will be like that, but I'm saying in general, okay? Now, when it comes to similar way, when it comes to typical element, I say that those elements which represent the characteristic of their group, they are known as basically typical element. And here I'm talking about, let us try to understand that. Suppose I'm talking about second period, which is lithium, and it will end at neon. I'll be writing the configuration as 2s1. This one will be 2s2, 2p6. Now, if at all I go for sodium, this one will be 3s1, and this one will be ending at argon, which will be 3s2, 3p6. Similarly, if at all I go for the next one, which is potassium, I'll be writing 4s1, and then it will be ending at krypton, which is 4s2, 4p6, right? Now, these are second period elements. This is third period. Okay. This one is third period. Let me write down here. This is third period element. Then you are having fourth period element. Okay. Now, when it comes to second period, maximum number of electrons which can be accommodated into the second shell is how many? 6 plus 2, 8, right? Beyond 8, can you have like, does 2D exist here? Does 2D exist? 2D subshell, does it exist? If at all you are having little bit knowledge, so you should tell me, does 2D exist? No. That means maximum how many electrons can come here? 8. Now for the formation of bond, for one bond, how many electrons required for the formation of one bond? For the formation of one bond, how many electrons required? One bond I'm talking about. Just 2 electrons. So if at all I'm having 8 electrons, how many bond I can make? How many bond I am referring to? 4. Total 4. If at all I am having 8 electrons, so I can make at max 4. So when it comes to the second period, at max they can only make 4 bonds, right? And I'm talking about second period in general. You do not just focus on, kind of neon there, right? You may say that, ma'am, there is no compound of neon. I agree, right? But I'm talking about the entire period there, okay? Now, when it comes to sodium to argon, I have moved to third period, right? In the third period, you're able to see this is 3s, 3p, and there will be vacant 3d. Vacant 3d means 3d is there which is unoccupied, right? And we know that sulfur which is there, it is a third period element. And do we know that sulfur structure will be somewhat like this here? How many bonds this sulfur has made in this compound? How many bond? How many bond sulfur has made in this compound? 6 bond. 6 bond means it is able to expand its octet, 12 electrons, right? So if at all it is able to expand, the rest other group members will also be able to do, right? So the thing is, what eventually I want to say here is, whether second period element is representing the characteristic of group, or else third period elements are representing more of the characteristic of the group members. Which one? Second period element or else the third period element? Second period element or the third period element, which is more likely to represent its group members' behavior? Absolutely correct, Sashi, it is third, right? Second one is different, right? So all of you have answered correctly, Lakshmi, Varsha, Ishwar, right? So that's what is the underlining principle here, that ultimately third period elements are actually known as typical elements because they are representing the properties or the characteristic of their group here. So I'll write down third period elements, that is sodium to argon, are typical elements, as they represent the characteristic of their group. The characteristic of their group. Right? Now next one we are going to write down as normal or representative elements. First you finish off writing for typical, then we'll proceed further and write down done if it is written over there. Finished? Okay. Now when it comes to normal or representative elements, right? So which block elements are known as normal elements? Which block elements are known as normal elements? We generally say those elements which are having their outermost shell incomplete are normal or representative elements. Ideally, it should be S block, P block, and in P block, we should not consider 18th group, right? But in your NCRT, they have not mentioned anything about, kind of exclusion of your 18th group. That's the reason, according to NCRT, whatever definition is given, we are going to prefer to that, right? So the thing is, you should only remember that S and P block elements, we are calling them as normal elements, okay? And we also call them as representative elements because if you see in your periodic table, you are having like majority of, kind of S block, P block, only few of your D and F block elements are there. So it seems like major chunk of the periodic table or the major representative of that periodic table is your S and P block element. And that's why we say that representative element. I hope it is clear to you, right? So I'll write down here S and P block elements are called as normal elements. Right? Shall we proceed further now? That beta? Okay. Now, let us go for the next one here, which is transition element. Now, when I say transition element, what do you understand by that? Can I call any element as transition element, or there has to be something which should be very specific about? Correct. Can I, Vamsi has written D block element, right? But can I say all the D block element I can randomly call them as transition element, or they have certain criteria? Okay. Fine, that is the property which they are exhibiting with her, but why do I call them as transition element? Correct, absolutely pointed by Sashi here. Incompletely filled D, subshell I'll say, not orbital atom, right? And definitely we are calling them as transition element because they are having their properties, somewhere we feel like it is transiting from very reactive metals to least reactive non-metal towards your group 18. That's absolutely fine, right? So here I am saying that those D block element which have partially filled D subshell either in the ground state or in any stable oxidation state, and those oxidation states should not be imagination of your brain. Okay, that oxidation state must exist. So I'm writing here the D block elements which have partially filled subshell, partially filled D subshell. D subshell either in ground state or in any stable oxidation state, or in any stable oxidation state. For example, if I go for copper, you know that for copper, what is the configuration we are going to write down? In terms of inert gas, you should be comfortable writing the configuration. So before copper, the inert gas which comes around is argon, right? Now the thing is, argon, I'll be writing here 4s1, 3d10 here. Now, if you look at the ground state configuration, you might feel like, it is 3d10 fully filled. So it should not be a transition element. No, but you have to wait for, there is like in stable oxidation state also, is there chance of partially filled D subshell or not? So if you go for Cu plus 1, you will be writing this as argon 4s0 3d10, right? Here also you might consider, but the thing is Cu2 plus is also existing, no. So you'll be having argon 3d9. So it is having here partially filled D subshell. And that's the reason it is called as transition element. So I'll be calling this as, therefore, transition element. Now, if at all, contrary to that, if I go for zinc, zinc is 30 actually, right? If I go for zinc, I'll be able to write down this as argon 4s2 3d10. So in ground state too, you are not able to see any, completely filled D subshell is there, right? So I am not able to declare that. Now, even there is only one oxidation state in which your zinc will be existing. So for D block element, always we remove from the outermost shell, which is fourth here. Outermost shell is still fourth, okay? Do not think it is third. So we are going to remove the electron from Ns. So it will become here argon, and the thing is it will become 3d10. So both the places, whether it is ground state or else it is your stable oxidation state. In both the places, we are having fully filled D subshell, and hence we are not able to count or treat this as a transition element. So I'm going to write down this as, this is fully filled D subshell, therefore not a transition element. So please write it down, then we'll proceed further here. One or two note I'll give you. Once we are done, let me know. Finished? Now, let us go for the next one here, which is note. So can you tell me, can you recall what are the elements which are present in the same group of your zinc? What are those? Can you just enlist the elements which are present here? Vamsi has pointed out. Correct. Zinc, cadmium. I told you, na, zinc in Cadbury and mercury in your cone, right? So all these elements are following the same thing. That means the way zinc is not a transition element, so these are also not the transition element, okay? And it's easier to remember. So I'll write down zinc, cadmium, mercury, copernicium. All these are group 12 elements and they are not transition element. They are not transition element. Got it? Then let us go for the next one here. And I'm going to tell you, like, say one statement, just identify whether the statement which I'm saying is correct or incorrect. Okay. So if I say that all the transition elements are D block elements, all the transition elements are D block elements. Am I correct? All the transition elements. I said all the transition elements are D block elements. That's absolutely correct. Because I said zinc, cadmium, mercury, they are D block element now. Because the last electron is entering into D subshell. Okay. So they are definitely D block element. Okay. What about if I say that all the D block elements are transition elements? Can I say like that? All the D block elements are transition elements. Can I say like that? Absolutely, I cannot say like that, right? Correct. So let us write down this, and they may ask you in the form of a statement. That's the reason I'm asking you here. So let us write down all the D block elements are not transition elements. Whereas all the transition elements are D block elements. Are we done writing this note? Then we'll proceed to the next one. Now the next one is transuranic elements. What do we understand by transuranic elements? What do we understand by transuranic elements? Correct. Raju has written there and Sunday also. So those elements which come after uranium. Can you tell me what is the atomic number of uranium there? Absolutely fine, Geeta, Raju. What is the atomic number of uranium? 92. So can I say all those elements whose atomic number is greater than 92 are transuranic elements? Okay. So I'm writing that here. The elements after uranium are transuranic. And here I'll be writing their atomic number should be greater than 92. Or else I have written lots of shortcut here. So their atomic number must be greater than 92. Done? No, but they are not called as rare earth. Rare earth elements will be basically your all those F block elements. Okay? So in this also few F block elements might come because 90 to 103 is F block element only. Na? Samita, I hope it is clear, right? Then let us go for the segment which is very important. How to predict period, block and group number for the elements, and this is highly important. Now at present I am simply writing like the formula, just take it as formula. We'll try to understand each and everything, need not worry about. Okay, so here for predicting, identifying the period number, how do we get the information of period number? Do we recall a little bit also? Highest n value, that is highest principal quantum number, will give me idea about period number. So I'm going to write down this as maximum n value. When I say n, that means this is principal quantum number. And this principal quantum number gives you information about shell. Okay. Now, next one is you have to find out now block. How do I judge whether a particular element is S block, P block, D block or F block? On what basis we judge? On what basis do we judge? we try to say that basically in which subshell your last electron is entering. If it is entering into S subshell, we say S block. P subshell, then it is P block, like that we say. So we are going to write down here the subshell in which last electron enters. Okay. Then this is the sequence in which you should go, right? First identify period, then after that you identify the block, and after block only you should find out the group number. Okay. Now when it comes to group number, then if at all it is S block. So for group number we just need to see NS electron. That means valence shell electron. In the outermost shell, how many electrons are there? That will decide your group number for S block. Similarly, if at all you are having P block, so for P block you can have 12 plus number of electrons in NP subshell, and there could also be like 10 plus NS and NP electrons here, and this is actually valence shell electrons. But I would suggest that please stick to this 12. What is the reason? I'll tell you. There is no harm in writing 10 plus NS plus NP. But the problem is the moment you people get to know that it is P block, you go into such an excited state that you forget to count the number of NS electrons and eventually get -1. That's the reason I'm saying 12 plus NP electrons, you remember. There is nothing incorrect about the formula, right? Then, if it goes for D block, for D block, we simply say NS electrons plus N minus 1 D electrons, right? So NS plus N minus 1 D electrons will give me the group number in case of D block. At present, just think that you are writing a list of formulas, nothing more than that, okay? Then, for F block, always remember group number is 3, always. There is no doubt about it. Okay, please write it down, then we'll proceed further. Are we done writing the formula? Let me know. Done? Okay, now there are few steps here which you must know for identifying. And that will be much more easier for you, right? So what kind of question, or else in which form question can be asked from this segment? So you can think that either a direct atomic number might be given to you. That means they may write down, this is the symbol of the element and this is the atomic number, right? They may give you the atomic number directly, or else they may give you the electronic configuration written, right? So what you have to do is, if atomic number is given, well and good. If electronic configuration is given, you simply, kind of add it up all the electrons, right? And then you try to convert that into the corresponding atomic number. Okay. Now, once you have done that, so that atomic number which you have got, please try to refer to the previous inert gas and try to predict the period, block and group number, right? That is what is the procedure. And normally, because when like 5F, 4D, all these things come, then there could be more confusion. That's the reason I'm saying that to avoid confusion, you can go like that, right? So I'm going to write here in the question atomic number or electronic configuration, EC is electronic configuration of the element may be given. Convert electronic configuration of element into the corresponding atomic number. That means you are simply adding up the electrons which are present in different subshell. Okay. Then next what you have to do, using the previous inert gas. Previous inert gas means the inert gas before this atomic number. That is inert gas appearing before the given atomic number. Try to predict period, block and group number for the element. Do not worry about it, we'll see to it. Now what is the meaning of this is, you must remember that helium, neon, argon, krypton properly, right? And that will be always helpful. So I'm writing here group 18 and I'm writing helium, neon, argon, krypton, xenon, and then you are having here radon and oganesson. As such, oganesson is not much required because oganesson is actually the last element here, right? And their atomic number 2, 10, 18, 36, 54, 86 and 118, right? Now for helium, helium is marking the ending of first period, right? So first period ends here, second period ends at neon. Then we are entering into third period. Third period ends at argon, likewise, right? So I'm writing here, first period ends here. Similarly for neon, I'll be able to write down second period's end here. Third period ends here. Fourth period ends here. Fifth period ends here. Sixth period ends here. And this is like seventh period ends here. Right? Then I'm writing down the configuration here, S, SP, SP. In fact, this is the energy order, SP. In the fourth one, I'll be writing SDP. Fifth one also SDP. SFDP. And then I'll be writing SFDP. Remember, we have written that energy order in which the electrons will be getting filled up. First shell 1s, second shell 2s, 2p. So I have not written 2 here, but it means 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p. Like that we are going. This will help you out to write down the configuration. That's the reason I have written that. And it's very important for you to know how to write down the configuration of the elements in terms of inert gas. Have you written this? Then I'll tell you, kind of the application part of it. And here sometimes we tend to forget which marks the ending of which period. So helium, neon, quite easily you are able to remember. For argon, can you tell me how many lines are in this A? 3 lines, na? So it is marking the ending of third period. In krypton, 1, 2, 3, and like this here 4. Xenon, are you able to see Roman letter 5? 5. Roman letter 5 we'll be writing now. So that way you'll be able to remember. Otherwise, if you remember like helium, neon, argon, krypton, then also it is fine. Now, what is the usage here? Try to understand. I'm simply telling you some configurations, but I'm not telling you how to predict the period and block and group number at present. Simply the usage of this, whatever I've written. Now, suppose if at all I have to write down for magnesium, I know magnesium is 12, right? Now, just before magnesium, which is the inert gas, you cannot go beyond it. You have to go for previous inert gas or the closest, nearest inert gas to it. That will be which one? Closest to magnesium will be which inert gas? Neon or else argon? Previous inert gas. It has to be neon. So I'll be writing here neon, right? Now, once you have written neon, so neon is marking the ending of second period. Now you have to enter into third period. When I enter into third period, this is your third period. What is getting filled up there? S and P. That means 3S and 3P. So from this diagram, you will be easily able to identify. So I'll be writing this as 3S and 3P, right? If at all it is not required, I can remove, not an issue. So 10 electrons done. After that, 2 more remaining. So it will go here. This is not required. So we'll remove it, right? Similar way, let us go for, suppose I am writing here, let us say I am going for phosphorus, or let us say for arsenic I am writing. Chalo. Arsenic is 33. Okay? You tell me, you write down the configuration of arsenic in terms of inert gas, then we'll proceed further. Only configuration in terms of inert gas. Which inert gas is closest to it? All of you must write it, the arsenic configuration. Which is the nearest, or before this, which inert gas would have come? Argon, na? I cannot write down krypton. Krypton is beyond it. I'm asking about the inert gas before it. Argon. Now, argon marks the ending of which period? Argon marks the ending of third period. Now we are entering into fourth period. In the fourth period, what is getting filled up? SDP. So I am writing here 4S, 3D, 4P. So I am going to write down here 4S, 3D, 4P. Able to understand what I am writing here? Now, in argon, how many electrons? 18 done. 2 here, 20 done here. 10 here, 30, and you will be having here 3, 33. Correct, Rahman has written correctly. Able to understand what we are doing here. What is the usefulness of it? Okay, so you must be comfortable in writing the configuration. So you must know which one is marking the ending of which period, and then if at all we are ending into next period, which are the subshells which are getting filled up. So basically this is the energy level order of the subshells. I have not written here 5S and 4D and 5P like that, because I have already given you in the previous table which we have written. Getting it? Chalo. Now let us go for the next point here. Third one. So that is one way. Through inert gas you can go for, or else sometimes there are few ranges of the atomic number. If you recall or remember them exactly like that, then you need not even kind of write the electronic configuration. Or else if electronic configuration is given to you, you count the number of electrons and you identify whether the given atomic number is falling in the range of atomic numbers which I am giving you right now. Okay. So for example, let me ask you in general, if I say after lanthanum, it is cerium, right? 58. So 58 to 71. Which block elements I call them? 58 to 71. Which block element do I call them? These are the 14 elements there. 58 to 71. Not third block, but third group. It will be F block, and any F block element is in third group. Can you tell me what is the period number here? In which period it will be present? In which period it will be present? Sixth period. Absolutely correct, Lakshmi. Correct. Sashi here, Vinay here, right? Okay, so that range, if you remember, you are able to say block, you are able to say basically the period, you are able to say the group number. Now, going on the same line, if I ask you about 90 to 103, carry not, it cannot be in both 6th and 7th bit. If I am saying 90 to 103, in that case, which block elements are they? 90 to 103 atomic number. They are F block element. If they are F block element, they are present in which group? They are present in which group? Always third group. Which period? Last period, right? Similarly, if I ask you 104 to 118, which period are you able to find them? 104 to 118. Which period you are able to find? 7th. So if you count the total number of electrons from the electronic configuration and somehow it falls in these ranges, so answer is ready for you, right? So let us write it down here. If atomic number is in the between 58 to 71, we say that the period is 6th, block is F, and group number is going to be 3. Similarly, if I say that if atomic number is between 90 to 103, then the period here would be 7th, and the block here is going to be F block, and the group number is going to be again here 3. Write this down, then one will tell you. Now next one I am writing here. If atomic number is between 104 to 118, in that case, period is fixed, that it is 6th period. Period is not 6th but the last one, 7th period. And the group number will be given by last 2 digit of the atomic number. What do I mean by this? Suppose, for example, if I say 104, so the last 2 digit of this is 4 here. So I'll say that the group number here is 4th group. If what I'm saying 112, so the last 2 digit is 12th. So the group number here will become 12 here. One is Rutherfordium, another one is Copernicium here. Able to understand? Then, for block, we need to be little bit careful here. 104 to 112, that is D block. And if at all I am writing here, 113 to 118 group number, that is going to be P block. And this is also easy to remember because are you able to see group 13 to 18? For 113 to 118, last 2 digit is 13 to 18, and we know that group number 13 to 18 will be P block. Understood everyone what I have written here? Write this down, then we'll try to understand whatever I have written as a formula. Right? Few questions we'll do in the class and few questions you do it for your testing purpose. Are we done? Now, Let us try to understand. Suppose I am giving you here cesium. Cesium is 55. Now for your understanding, I am writing here helium, neon, argon, krypton, xenon and radon. I am not writing organization as such. 2, 10, 18, 36, 54 and this one is 86. Now tell me which inert gas is before cesium. Which inert gas is before cesium? Can I write down this as xenon, right? And xenon marks the ending of which period? Correct, Sandhya? Tell me, xenon marks the ending of which period? Xenon marks the ending of which period? Fifth period. So ideally we are entering into sixth period. Now when you are entering into sixth period, what is the what is the energy order in which filling will be taking place? SFDP. 6S, 4F, 5D, 6P, right? So I am going to write down here 6S, and let us say if at all it is required, I know what is the next thing. Required means depending upon if I have extra electrons remaining there, I'm not able to write down the configuration completely, then 6S, 4F, 5D and 6P, I should be aware about it. So you must know that after this xenon, fifth period ended, in sixth period which subshells are getting filled up. Getting it? So 6s, here this is 54 done and you are having one electron here. So it is done here. Now the maximum principal quantum number which is visible here is 6 only. So I am going to write down period will be equal to 6. Period is 6. And if at all I write down the block, which subshell is receiving the last electron here? Which subshell is receiving the last electron? Good that many of you, Satvik and Shrivalli and Harshit, you're writing it correctly. Which block it is? S block, correct. For S block, group number will be how many electrons in NS, because this is the value of N. So basically group number is going to be 1. Okay. Now let me give you another. Calcium. Go for it, everyone. I'm giving you small, 111. We are going to write it and predict. Starting with the smaller one only. Yes, Sashi, you are correct. Sunday also. Let us go for the next one. So before calcium, the inert gas which will be coming is argon. Argon marks the ending of third period. So I am entering into fourth. In fourth, what is the level which is getting filled up? SDP, right? So I'm going to write down here 4S, and I know that next if at all I want the subshell, it has to be 3D. So the thing is here it is 18, here it is 2. It is done, so I do not require D there. Tell me here what is the period? If you write, kind of open it up, you know that it is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. So rather than writing the entire thing, we are writing that in terms of inert gas. So whichever is appearing in the last, only if at all it is appearing the only one. So it is the highest principal quantum number. So period is going to be 4. The last subshell which is receiving the electron is S. So you are going to have block as S. And if at all I say about group, so group number will be how many electrons in NS? You are having 2 electrons. So the group number will become 2 there. I hope it is clear there. Good. Shall we proceed for the next one? Suppose I am giving you zirconium, or else let me give you first not zirconium here. Arsenic, you remember we have written the configuration. Can you write down for arsenic and predict which period, which block, which group? Do it, everyone. Then few more problems will do. Rahman is correct there. Harsha also. Yes, Sashi, absolutely fine, beta. Then, for arsenic, inert gas is argon here before that, because krypton is beyond it. Then, we are at argon, end of third period. So, we are entering into fourth period. So, we know that SDP should be there. So, I am writing here 4S, 3D, 4P. Here 18 electrons done, 2 here 20, 10 here 30, and you will be writing 3 here, right? Now, highest principal quantum number is 4. So the period here is going to be 4, right? And basically, if at all I go for writing here block, the last subshell which is receiving the electron is P, so it will be P block. And when it comes to group number, I'm going to write down 12 plus NP electrons. How many electrons in NP? 3. So I'm going to write down 12 plus 3 here, 15. And mind well why I'm saying that focus on 12 plus NP electron, because majority of the time what happens? You people read it as P block, right? And after that you simply remember 10 plus electrons in that, and this will be wrong. Right? It has to be 10 plus number of valence shell electron. Valence shell means in the fourth shell this will also come. So if at all you are writing, it should be 10 plus 2 plus 3. That will result in 15. This will be correct. So to avoid all such silly mistake, better remember 12 plus NP electrons. Outermost shell P electrons. Getting it? Okay. Now let me give you one more. Zirconium 40. Chalo. Predict the period, block and group number here. Absolutely correct, Vinay there. Very good. Here also, I think it's correct. Rahman, good. So before 40, the nearest one is krypton. Krypton marks the ending of fourth period. We are entering into fifth period now. So in fifth period, you are having SDP, right? So we are having 5S, 4D, and if required, we can write down 5P as well, right? Now, you are having here 36, 2 electrons done there, 38, and 2 more required, it will become 40. So I do not need to write down 5P, right? Now, maximum or highest N value is 5 here. So the period will be 5. The last subshell where the electron is entering is actually D here. So I can write down block is D block, and the group number is going to be NS electrons plus N minus 1 D electrons. So NS electrons are 2 here, and this one is also 2. You'll be having fourth group. Got it? Okay, now few more example I'll give you. Give it a try here. Now, the examples which I'm going to give now, they're just the atomic numbers, and it will be, kind of based upon whatever are the points which we have written there, right? It could be falling into the direct range, or else it could be like you have to write down the configuration. So it's your call, you have to judge it, okay? Identify period, block, and group number for the following. I am not giving you many, but still you can do it. Do these many, all of you. And once you are done, let me know. Fine, Raju, solve it beta in your notes there. I'll discuss it once the students are able to complete it. And once you are done, please write down done over there on the chat box on the app. Whoever is on the app there, Sri Gosalites app. Then I'll start discussing. How many are done there? I think many people have completed here. Not an issue. So you have to make a judgment that whether, if at all some atomic number is directly falling in the range which is given. So directly also we can predict there. Okay, Sashi has completed. What about other people here? Sandhya and rest of the people, Vinay, Sandhya. Okay, let us try to discuss this. For 8 atomic number, the nearest inert gas or the inert gas before that is helium, right? And helium marks the ending of first period. So we are entering into second period. In the second period, which thing or which subshell is getting filled up there? 2s and 2p. So I'm going to write down this as 2s and 2p. So here helium 2 electrons done, 2 here, 4 done. So I'll be having 4 here, right? So the period is basically 2. Block is, the last electron is entering into P. So I'll be writing P block. Group number is going to be how much here? Group number is going to be 12 plus 4. Why 4 from here? Please match your answers there. Verify the answers there. Okay? When it comes to 23, then nearest is argon. Right? Or before, that is argon. Okay? Then argon marks the ending of third period. You are entering into fourth period. So I am going to write down here in fourth period 4s 3d. If required, I can also write down 4p. Okay? Now here it is 18. Then you are having here 20 done. So 3 more electrons here. Highest principal quantum number here is 4. So the period will be 4. And the subshell which is receiving the last electron is D. So I'm going to write down block as 3. What about group number? Group number will be basically, the thing is NS plus N minus 1D. So because this is telling you n value, so I'm going to write down 2 plus 3. So this is telling me ns electron, this is telling me n minus 1d electron. So it is going to be 5. Able to understand? And please verify your answers there. Okay. Now when it comes to 38, the inert gas before that is krypton. Krypton marks the ending of 4th period. So we have to enter in 5th period. So I'll be writing, I know that when I move in 5th period, it is basically SDP which is getting filled up. So as in required, I can write down 4D and 5P. Now here 36 electrons done to here. So I got to know period will be 5. Last subshell receiving the electron here is S. So basically block is going to be S. And what about group number? Group number will be how many electrons in S here? 2. So it becomes second group. Good, Harsha. And here also I hope everybody got the answer, right? Now when it comes to 59, do you realize that it is falling in the range of 58 to 71? Do I need to write down the configuration? No. I know that directly 58 to 71, 6th period F block group 3, right? So here I'll be writing this is 6th period, block is F, group number will be 3. Now coming to this 43. So for the 43 atomic number or else the closest nearest inert gas or the inert gas which appeared before it is basically your krypton. Krypton marks the ending of 4th period. So I need to move on to 5th period. So I'll be writing 5s and let us write down 4d also. As required, we can write down 5p as well. This is 36 here, 2 electrons here, 38. I'll be writing 5 here. It becomes 43. Period is 5th period because highest principal quantum number. Block will be D because the last subshell which is receiving electron is 4d. And what about group number? Group number is going to be ns plus n minus 1 d electrons. That means this 2 plus 5. So I'm going to get this as 7. Able to get this there? Now, when it comes to 106, directly you know that 106, that means it is what? It belongs to basically that particular range, 104 to 18. So simply period is 7th, group number is 6. And what about block? Block is going to be D block. I know this is reverse here. D block. Now, let us go for the next one. 93. Do I need to write down the configuration? You know that 92, 103, that particular range I have given. So here directly, period is 7th, block is F, and you are having here group number as 3. Getting it? Now, similarly, 116, period 7, last 2 digit, group number is basically here. Group number will be 16, and if at all it is 16, then block will be P block because 13 to 18 is P block. Similarly, 63, I have given you between 58 to 71 range. So definitely period will be 6th period, block will be F block, group number will be basically 3. Now one more hypothetical element I have given you, which is 120. This is hypothetical element, and this is one of the question in your in-text NCERT, right? Now for doing such kind of question, just keep in mind 118 element is the last element which is present in 18th group. Now if 119 happens to be there, so 119 I'll be writing in group 1. Right, below francium. But below francium, when I write down, it will be coming in 8th period. Okay. Then 120 will be going into basically group number 2. Right. So here I'll be able to write down this will be hypothetically period number 8, and then block is going to be S block, and the group number is going to be 2 here. Able to understand here, everyone? So you can practice by, kind of giving yourself few atomic numbers, and preferably give yourself some atomic number from S block and P block. Reason being, you are having certain exceptions in case of configuration of your D and F block. So definitely I'll give you that in the next class, right? But at present, try to practice all these here, right? Hopefully it is absolutely clear there, right? So we'll wind up the session here only. Is that okay? We'll see next day. Okay. Thank you and have a nice day.